Okay, so what we've done so far is we've determined that this is going to be a quadratic, and we know we have those three sets of points, and we wrote three equations, so we have a system to be able to solve to figure out what those coefficients are going to be, what that a and b and c value are going to be. So I'm going to rewrite these three equations in a simplified form. So 3 equals 9a plus 3b plus c. 6 equals 16a, because it's 4 squared, right? Plus 4b plus c. Then we're doing 10 equals 5 squared times a, so that's 25a plus 5b plus c. Now there's multiple ways you could do this. One of the ways you could do it is through using matrices, but we don't teach you how to use matrices in Algebra 2. But the other way that you should know how to do is linear combination. Now, most of the time when we were doing linear combination, we only had 2 equations, but this time we're going to use 3 equations. So I'm going to label them as equation 1, equation 2, and equation 3, just so we can keep track of them. So if you remember, linear combination is like adding or subtracting 2 equations together to try and eliminate one of the variables. So I'm going to start by doing equation number 2 and subtracting equation number 1 from it. So equation 2 is 6 equals 16a plus 4b plus c. And I'm going to subtract from that equation 1, which is 3 equals 9a plus 3b plus c. And when I do that subtraction, I have to subtract each like term. So 6 minus 3 gets me 3. And 16a minus 9a gets me 7a. And 4b minus 3b gets me 1b, and c minus c leaves me with no c's. So now I have one equation with 2 variables. So I'm going to do 2 different equations, or a different combination of equations, to try and get another equation that's similar to that. So I'm going to choose to do equation 3 and subtract equation 2. So equation 3 is 10 equals 25a plus 5b plus c, and I'm going to subtract from that my 6 equals 16a plus 4b plus c. I'm going to do the same thing, subtract my like terms, so 10 minus 6 is 4, 25a minus 16a is 9a, 5b minus 4b is 1b, and then c minus c is 0. So now I have 2 equations in 2 variables. So I'm going to kind of do the same process, but now I'm going to use these 2 equations. So I'm going to start with the 4 equals 9a plus b, and I'm going to subtract 3 equals 7a plus b. All right, so when I do the subtraction, I get 1 equals 2a. Basic solving, I subdivide both sides by 2, and I get 1/2, or 0.5, equals a. All right, well, there is one of my coefficients for my equation. Now I need to find out b. And I'm allowed to use any of these equations that I've set up, including this one that only has an a and a b in it. And that's going to help me because I can substitute in the value of a now that I found out and calculate what b is. So I'm going to take this a value, bring it up here, and put it in this equation. 9 times 0.5 plus b. So that's 4 equals 4.5 plus b. Subtracting 4.5 from both sides leaves me with negative 0.5. So that quickly, I've got an a value, a b value, and now all I have left is the c value. So I can use any of my original 3 equations, substitute in an a, substitute in the b, and find out what c is. I'm going to use this top one just because it has the smallest of all the numbers. So 3 equals 9 times my a value, which is 0.5, plus 3 times my b value, which is negative 0.5, plus c. Now if I do some simplifying, I've got 3 equals 4.5 minus 1.5 plus c. So 3 equals 3 plus c. And subtract 3 from both sides gives me that c equals 0. Now I can take And remember, my original form of a quadratic is y equals ax squared plus bx plus c. I can now fill in that a, b, and c. So y equals 0.5 x squared minus 0.5 x plus 0. So I'm not going to write anything. This is a polynomial that could tell me how many roads I need for any given number of cities. So for instance, if I have 10 cities, how many roads do I need? Well, y is going to equal 0.5 times 10 squared minus 0.5 times 10. Well, 10 squared is 100, and half of 100 is 50, and half of 10 is 5. So that tells me if I have 10 cities, I need 45 roads. So this is a pretty long process. The calculators can do it easier. If we were in school and had our 84s or our Inspire calculators, we'd be able to get the calculator to do the regression for us. But you should also be able to do quadratic regression by hand. I'm sorry, not regression, quadratic, solving the system of 3 equations by hand. When we go to do the cubic regression, I'm going to show you how to do that on a calculator on the computer.